Welcome to Spring LIB.
Okay, so during chapter 35, problem 39, so we want to show that second and third order spectra of white light produced by a diffraction grating will always overlap, and then figure out what wavelengths overlap. Okay, so to start this, we need to realize that angles increase with wavelength. So we can compare the maximum angle for the second order with the minimum angle for the third. So our equation here tells us that d sine theta is equal to m lambda. So if we're trying to find the maximum for the third, so this will be, we can just take, since we know that, or we can take d sine theta of the second order is equal to 2 lambda, and I'm going to call this lambda 2. This is the max wavelength for the second order, and we can divide this equation, divide both sides by, for the third order, this equals 3 lambda 3. So we should see immediately that these d's are going to cancel out. And what we see here is, so we can set what we can set is the maximum wavelength for the second order is going to be 2 times 700 nanometers for white light. That's the maximum wavelength for that. And then we can take the minimum wavelength for white light or visible light for lambda 3, which is 400 nanometers. And we see that the ratio in their sides here is going to be given as 1.2. So now we got to figure out what wavelengths are going to overlap. So what we can do here is see that sine theta 2 over sine theta 3 here, we can set this equal to 1, because that's what happens when they overlap. So from this, we see that this equals 2 lambda 2 over 3 lambda 3, because we already figured that out. So from this equation, we can find lambda 3 based on the max lambda 2. And vice versa, we can find lambda 2 based on the minimum for lambda 3. And what these comes out is we get 2/3 times the max lambda 2, we already said was 700 nanometers. And for lambda 2, we get 3/2 times the minimum, which was 400 nanometers. So if we plug that in, this comes out to being 467 nanometers for lambda 3 and 600 nanometers for lambda 2. So what that means is, this kind of seems like a lot of numbers here, but we didn't really, it might seem weird that we didn't really solve this problem yet. But we did, because we said these sines are equal to each other, the sine of both angles. And we can found that for the max to, or we found minimum. So this is the minimum for 2. So the range here that overlap is lambda 2 to lambda 2 max. But we already found lambda 2 was 600 and lambda 2 max is 700. So this is our range for lambda 2. And for lambda 3, we know the minimum is what we know, and then we found lambda 3 where they overlap. So this becomes 400 to 467 nanometers. Okay, so these are all the spacings that actually overlap. Cool.